Hello everyone, welcome back to another video where I teach you organic chemistry and you listen to get those A stars. Right, so today's lesson is going to be about another family in the organic branch called alkenes. Now, alkenes are just like its sibling alkanes, but there's a few differences and we'll go over them right now. First of all, let's just write down another family of the organic branch. All right. Now, the difference that alkenes have from alkanes is that they contain carbon molecules with double bond. See, C to C double bond contain a double bond between carbon atoms. Their structure goes something like this. I'm going to draw you structure of ethene. So structure goes something along this. So you can see there's a double bond right here. That's why there's no hydrogens on the left side. See, there's no hydrogen over here or over here because the double bond has taken that position, frankly. Now, let me explain what goes on here. You see, these bonds are all sigma bonds. See, this is a symbol for sigma, and this is a symbol for pi bond. But this one, the double bond here, is actually a pi bond. So there's one sigma bond and one pi bond between the carbon atoms. The pi bond keeps everything locked. It's like a hinge. That's why alkenes can form isomers more easily. Moving on to the general formula. The general formula is similar to those of alkenes, but slight difference. So right, general formula, and this is going to be CnH2n. Let me just put this in a box so you guys can remember it. CnH2n. Now, do you guys remember what the formula for alkanes was? If not, I'll write it down again. The one for alkanes was CnH2n plus 2. Now, you see, there's a clear difference between them. They're similar, but there's difference. In alkanes, the hydrogens will always be double plus 2. Yeah, so in alkenes, there will always be double the amount of hydrogen, but in alkanes, there will always be double plus 2. If you want examples, I'll give you some of them. Now, take a look. Alkenes basically start from ethane, right? Ethene, sorry. So it starts from ethene because there must be a double bond between two carbons, and below this, there's no second carbon. So ethene goes some C2H4. Next comes on propene. Propene. It goes around C3H6. Let me draw structure of propene for you. So one carbon, two carbon, three carbons. Now we draw one hydrogen, two hydrogen, three hydrogens, four hydrogen, five hydrogens, six hydrogens, seven hydrogens, eight hydrogens. Now we simply put a double bond over here. The rest we can remove. Now let's see how many bonds does this have? One, two, three, four, five. We know carbon cannot form five bonds, so we will simply remove one hydrogen from here. This one also cannot form five bonds. So we will simply, my bad, we will remove the hydrogen from here. So as you can see, there's C3H6. How? Let's count. 1, 2, 3, 4, 5, 6. So moving on, let's draw butene. Moving on, let's draw butene. Butene is C4H8. Here's where things actually get complex. So butene can be drawn in two ways, but1-ene and but2-ene. Let me draw a structure of but1-ene for you first. Let's move down. But1-ene. Basically, it goes along like 1, 2, 3, 4. Put a double bond over here. 1, 2, 1, 1, 2, 1, 2, 3. So you can see why is it called but1-ene? Because the double bond is on the first carbon. You can see the double bond is right here on the first carbon. If the double bond was here, it would still be called but1-ene because we take a look at the longest chain, right? So this is basically the longest chain, and we always start naming from one side. We cannot go in choosing like this as the first carbon. No, that's wrong. We always have to choose either this as the first carbon or this as the first carbon. Now let's draw but2-ene. 1, 2, 3, 4. Now double bond over here. See, second carbon. We have to put it on second carbon. This is the first one, not accepted. This is the first one, not accepted. This is accepted and this is accepted. So it's a second carbon alkene. So it's called butene. That's why. Now let's just put the hydrogens one, 2, 3, 1, 1, 1, 2, 3. Now let's see how many hydrogens are over here. Counting 1, 2, 3, 4, 5, 6, 7, 8. So C4, H8, and here 1, 2, 3, 4, 5, 6, 7, 8. Again C4, H8. Now, for physical properties, how I like to remember is I keep the word cows in my mind. It might seem strange to you, but hear me out. See, this is colorless, this is odorless, this is soluble in organic solvents, not in water, okay? Because it's non-polar. I'm just going to write it down for you as well. Soluble in organic solvents. Now, listen to W, okay? So, they are more dense than air. You can think of W as weight. You can think of W as weight. These alkenes will fall downwards if you release them into the air. So you can call them more dense. That's why I'll write more dense than air, more dense than air. Now moving on further to chemical properties. Right, so this one has a bit more chemical properties than those of alkanes. Let's run it over. First of all, combustion. Combustion is a shared property between both. I taught you how to do combustion equations back then, and I'll write one for you here right now as well. So C2H4 plus oxygen forms carbon dioxide plus water. Two carbons on the left side, two carbons on the right side, four hydrogens on the left side, then four hydrogens on the right side. Let's see how many oxygens. One, two, three, four, five, six. We simply put a three here. Next, addition reactions. Now, this might be new for you because this is unique to alkenes right now. How? What do I mean by addition? Now take a look at this, right? So C double bond and then plus we add bromine, right? Bromine. This forms basically, this double bond will break. Let me just visualize it for you. What happens is that the bromine attacks this double bond and this breaks, it just breaks down. This allows bromine to be added over here and over here. And this is just not bromine, you can add anything. You can add stuff like HCl, you can add chlorine. The addition reactions can have a lot of variety in it. Now let's complete the equation. So the final equation is going to be like this. So this is bromine, this is bromine. This is hydrogen, 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 hydrogen. Now, one more thing that this does is free radical substitution, and that only happens in the presence of UV light. I'm just going to write free radical subs. Okay, basically, let me just write this in presence of chlorine, chlorine and UV rays. I'll teach you free radical substitution in another video because over here it might get a bit too complex. You guys should focus on the rest of the things that I said, but don't worry, I'll teach it to you. Moving on further, hydrogenation, or you can call this a reduction reaction. Hydrogenation. Again, what happens is the C double bond right here, you add hydrogen to it and it forms one, two, three, four, five. Yeah, it forms an alkene. So an alkene to alkane happens when hydrogenation takes place. If instead of hydrogenation there were hydration, basically the addition of hot steam, an alcohol would be formed. Let's check. Plus H2O forms OH, right? These are all hydrogens and this one is OH. So this is an alcohol. Hydration basically moves an alkene to an alcohol basically. And lastly, but not the least, polymerization. Polymerization is an important one because you might be asked to draw a long chain of polymers. Basically, how polymerization works is, see, there's an ethane molecule right here, see, and now there's another ethane molecule right here. Now, if they want to join, what will happen is that both of them will abandon their double bond and they will form a bond between, right? And then they will continue this chain. Let me just draw it for you so you guys can understand because this comes in your CEIs and they will ask you about this. So, Carl, let's see. So here you go. This is called polyethylene. You know those plastic bags that you use? They are made of polyethylene. That because simply the fact is that poly means multiple and ethene is the base compound that it's made from. So this is ethene as I mentioned above, and then this is polyethene, this entire stuff. And you add these brackets at the end to show that there's an endless chain. You know, it keeps on going and going. But remember, you have to show these dashes as well. Otherwise, you won't get marks. So guys, hope you learned something valuable from this video. If you did, make sure to like and subscribe to my channel and stay tuned for more organic chemistry videos. Till then, guys, goodbye and best of luck.